Let us master the real life application questions based on quadratic functions. Enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we are taking up very important questions from final test point of view. We are discussing functions MCR3U. In this video, I am going to share with you the solution of question number 10 from our final test paper 2024. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. You can also join our fast track classes and get ready for the new session in September. The question here is: an engineer is designing a parabolic arc. The arc must be 20-meter high and 8-meter wide at the height of 10 meters. Part A is: determine the quadratic function that satisfies the given condition. Part B is: what is the width of the arc at the base in exact form? You can always pause the video, answer the question, and then look into my suggestion. Now, the difficult part here is to sketch the diagram and have the right reference frame. So, we'll discuss this part. It's a great strategy. So, once again, what we are given here is an arc. So, we'll assume that to be a parabolic path which can be represented by a quadratic function, right? This is what we want. 20-meter high. So, let's sketch one. And so, it should be something like this, right? And the height of this is given to you as 20 meters, correct? Now, here's a complicated condition which says an 8-meter wide at the height of 10 meters. So, let me use another ink here. So, halfway, this width is how much? So, here, when the height is 10 meters, right, then it is 8-meter wide. You get a clear idea, right? So that is what it is. And we need to first find the function itself, the equation of this quadratic function. And then we also need to find the width of the arc at the base in exact form, which is this much, right? So, which you could take as x-intercepts, right? Great. So, I hope with this, now it is easier to solve the equation. Perfect. So, let's begin the solution. So what I'll do here is take a reference frame, the y-axis going through the peak, right, representing the height, and the x-axis is where we want to find the width, right? What could be the equation? Since we have the vertex parabola opening downwards, which is 20 meters above, we can write the function as y equals to minus, we don't know the value of a, but we know that it is ax squared, but the maximum is 20, so it is plus 20. So this is the best equation to begin with. You get the idea. Now, we are also given two more points here. If that becomes a reference frame, then 8 meters means 4 on either side. So this coordinate point will be 4 along the x-axis and 10 along the y-axis. So we have a point, let's call this point P as 4, 10. Makes sense? Because the width is 8, 4 on each side, and the height is 10. Substituting this, we get 10 equals to minus A, x value being 4, right, plus 20. So we can bring this negative A to the right side to be A, and 4 square is 16, right, equals to 20 minus 10, which is 10. So the value of A is 10 over 16, which you can simplify dividing by 2, we get 5 over 8. Makes sense? So we get a quadratic function now. So what is the quadratic function for us? The quadratic function is y equals to minus 5 by 8 x square plus 20. Perfect. So that becomes the quadratic function. Part A is done for us. And now you can find the width of the arc at the base, right? That means when the height is 0. Is that clear to you? So let's go to a fresh page and find the solution. We already have the equation in the form y is equal to minus 5 by 8 x square plus 20. Right. So here is the parabola which we are working on, right? And what we need is to find the x-intercepts right there. So means what are the x-intercepts? The y value is 0. Perfect. So we can write this as 0 and then solve for x. So that gives you 5 by 8 x square equals to 20. Is that clear? So we can say x square equals to 20 times 8 by 5, which is 4 times 8, right? 4 times 8 is 32. So x is equals to plus minus square root of 32. And 32, now we want it in the exact form, right? No decimals, right? 32 you could write as 2 times 16, right? So x equals to plus minus 4 square root. Makes sense? So we have minus 4 square root 2 and plus 4 square root 2. And we need to find the width at the base. So we need to find this. That means the difference. And therefore we can write the width is how much? Will be twice this, right? Twice 4 times square root 2, which is 8 square root 2. And the units are meters. It is very important to write down the units, otherwise you might just lose 0.5 marks. Make sense, right? So we done this question, parabola with maximum height of 20, and it was very easy to solve since we have taken y-axis along the vertex, right? And so it became a very simple solution, and that is the strategy. So what you learn here is how to define your reference so that the problem becomes simple. I hope it makes sense. Feel free to write your comments, share your views, and if you want to really learn and excel, you can always contact us on globalmathinstitute at gmail.com. Our students are right there on the top, getting awards and scholarships and admission to the best universities. You can be there. Thanks and all the best.